Right, so this video is going to be about what is an angle and then different angle relationships. So first, what is an angle? Well, when we talk about angles, we're talking about the space between two intersecting lines or two surfaces. Okay, so if you think about a ruler, let's say you have a straight line. If you want to measure that straight line, you could get a ruler, you could measure it in centimeters, inches, many different things, okay? But what if you had two lines that actually intersect each other, okay? So let's say we had two lines that intersect each other, and I said, what is the distance between these two lines? Well, you could measure the distance from different points. So then what have I said? Okay, well, what is the space between them? What is the space from this line to this line? So what is the actual turn we would do? And this is where angles come into it. So what would this line have to actually move to get to the other line? And that is what an angle is talking about. If we're measuring an angle, we're measuring the space from one line to another. And it doesn't matter if you're talking about starting from here or you're starting from here. If you're talking about an angle, it's just talking about how does this line go to the other line or a surface. When we measure angles, we measure it in either degrees or radians. We're going to look at just degrees. But if I was measuring the space between these two lines, I could use a protractor. I would put this point and this line. I would put the point right at the center, and I would put the line so it's at 0. And then I would measure where this line here would stop. So I would go round on the side, and wherever the line stopped, I could read off. And for example, it might be 60, and that is the size of the angle. What is the space between the two lines? The first thing we need to be able to do then is we need to be able to label an angle. So you'll be given some information, and we need to know what angle are you talking about, because in some questions you'll have multiple angles on the screen. Okay, so this first one here, they might give us some information, and they may give us points on the rays, on the lines here. If I want to explain I'm talking about this angle here, I could say, well, these two lines intersect at B. So I could say angle B, or I could say angle ABC. So that means you're going from A, B, and C, and the angle that forms, that is what you are talking about. And you could also do it C, B, A. As long as that vertex B is in the middle, I know we're talking about this angle here. In this question, you can just use B because there's no other lines coming off it, and it's only labeling one specific angle. However, in this question, let's say that I had A, B, C, and D. In this question, I could be talking, if I just wrote angle D, I could be talking about multiple angles. So to make it a little bit clearer, we're going to use when we have 3 points. So if I want to talk about this, just the space from this line that has A on to this line that has B on, I would say angle ADB. D is where they intersect, and I'm only talking about the space from A to B. If I'm talking about this angle, so just the space from the line with B on and C, I would say angle B, D, and C. Again, D is in the center because that's where them two lines intersect. But what if I want to talk about the whole angle? So I want to talk about how we go from A and we get to C. So them two angles together. So if I want to say that I'm talking about them, I would say angle, the line with A on, they join at D, but I want to know what is the angle all the way to C. Again, D is in the center because that's where the line with A and C join. Right, this angle, and at the end, I'm going to give you an example where it might just label the actual angle themselves. So it might say angle Y, X, and Y. Okay, it's a little bit easier. It's actually put variables within the angles, and you can say angle X equals something and angle Y equals something. Again, with the triangle, they might give you variables within the triangle. So they might say you have, this is angle A, this is angle B, this is angle C. Makes it a lot easier. If it does not, it might give you the vertexes again, so the corners. So it might say this is X, Z, and Y. And if I want to talk about angle C, for example, I can say that it is either angle Y, or I can say it's angle X, Y, and Z. Again, the Y would be in the center because I am talking about this angle here. And then you could have a complex shape on the side. So we have angles all over the shape. We have large angles. We have smaller angles. We have angles that would join together. Okay? Again, depending on what you're talking about, it might label it. It might just say, okay, this is angle X. What is the measure of angle X? Or it might give all the corners a letter to represent it. So we might have A, B, C, D, E, and F. And if I want to talk about this angle in particular, maybe, and it doesn't have a variable inside, I could say it's angle E, F, and D. The next thing we're going to talk about then is different, not how to label it, but just different names of angles. Okay, so if two lines intersect, we have a relationship. So we have this angle and this angle are exactly the same. They would be congruent. And this angle would be congruent. So if two lines intersect and they're straight lines, we call them vertical angles. They are vertically opposite and they are congruent. They are equal in measure. This sign means congruent. If you have two angles that are next to each other and they have a common wall, so they have a side that is common, okay, we call these adjacent angles. So if two angles have a common wall, we call them adjacent angles to each other. If you have an angle, and this symbol right here means that we have a 90-degree angle, it is called a right angle or a complementary angle, depending what curriculum you follow. And the last one, if you have angles that form a straight line, just like a protractor forms a straight line, it equals 180 degrees. We say that it's a straight line or it's a supplementary angle. If you have supplementary angles, it equals 180 degrees. Okay, so there are different types of relationships that we have. I'm going to refer back to this right angle here and this vertical angle. If I have two lines that intersect, and I know that one of them is 90 degrees, is a right angle, the relationship between these two lines is they are perpendicular. I have perpendicular lines. Perpendicular means that they meet at a 90-degree angle. And all of the angles will be 90 degrees for various reasons. Whether it's vertical angles are equal, whether it's angles on a straight line are 180, but we call that they have a special name. It is perpendicular if two lines intersect at a 90-degree angle. Right, the last thing I want to show you is then, depending on the size of the angle, it has different names, okay? So we're going to have a little look at, depending on the size of the angle, what could we call that angle? Okay, so if we look on this protractor, you will notice that it only actually goes up to anything from 0 to 180 degrees, which is a straight line. You have other protractors that go all the way around, but if you think about it, if a straight line is 180, if I continue till I made a full rotation, 180 and 180 would be 360 degrees. So a full rotation, so when you go all the way around, is 360 degrees. So let's have a look at the different sizes. So this angle here, you can clearly see if I started from 0 and I measured, this would be less than 90 degrees. So we call this an acute angle. If I take the second one, if I put that exactly on this protractor and I start from 0 and put it on a right angle, it is 90 degrees. It is what we call a right angle. This third one, you can see the angle here is greater than 90 degrees, but it's less than 180 degrees. We would still be able to measure this on this protractor. This is called an obtuse angle. The fourth one, you can see it's clearly a straight line. It would fit perfectly on that straight line on that protractor. It is just a straight line. It's 180 degrees. This one, the fifth one, you can see it's greater than 180. It wouldn't fit on this protractor, and we call it a reflex angle. It's greater than 180 degrees. That shouldn't be there, sorry. A reflex angle. When you have a reflex angle and you have a protractor like this, if you measure the angle on the outside, so let me just change that colour. So let's say we measured this angle here, because this could fit on the protractor, you could just subtract that from 360 to work out what the larger angle is. And the last one you can clearly see, it's a full rotation. So if it started from 0 and it went all the way round back where it started, it's a full rotation, which is the angle of 360 degrees.